You ever look at a world map and just wonder about the story behind it? I'm not talking about the lines humans drew, but the incredible, violent, and maybe even deliberate story that shaped the continents and oceans themselves. So today, we're going to dive into our planet's biography, a story that was written in fire, water, and cosmic collisions.
So that's the big question, right? How did our world get the shape we see today in an atlas? Turns out it's a wild story of incredible forces, working from both the outside in and the inside out.
All right, let's rewind the clock, and I mean way, way back, about 4 billion years. The Earth is this young, soft, kind of volatile place. And the first huge changes didn't come from within the planet, but from some really violent forces out in the cosmos.
So where did our oceans even come from? Well, get this. One theory is just incredible. Imagine a meteorite, the size of the moon, just slamming into the soft young Earth. It carves out this massive, gaping crater. Then, from deep inside the planet's core, fountains of superheated steam erupt. This steam billows up, cools into these unimaginably heavy clouds, and then it just rains and rains for ages, filling that giant cosmic wound to become what we now know as the Atlantic and Pacific Oceans.
And what's really interesting is that the source material connects this geological idea, water coming from inside the earth, to this particular reference in the Quran, which says that water was brought forth from the earth itself.
Okay, so we've got oceans. The next big piece of the puzzle was the air. And believe me, you would not want to breathe the air on early Earth. It was this toxic mix of hydrogen, methane, and carbon dioxide. It was the arrival of the very first green plants that completely re-engineered our planet. Through photosynthesis, they started pumping the atmosphere full of oxygen, creating the very air that all complex life, including us, needs to survive. A total game changer.
And the last major force from the outside? Our very own sun. The way it heats the land and sea unevenly creates these differences in air pressure. And that's what drives everything from a gentle breeze to a terrifying hurricane, constantly sculpting and eroding the planet's surface. But as powerful as all those external forces were, the true sculptor of our world was already at work, deep, deep inside the planet.
Yeah, forget meteorites and solar wind for a second. The most powerful architect of our planet is its own raging, molten heart. The real action, the force that builds mountains and literally moves continents, is happening miles and miles beneath our feet. You see, deep down, Earth isn't just solid rock. It's this boiling core of molten material, where the heat and pressure are so immense that they trigger what are basically nuclear depth bomb explosions. And the fallout from these deep Earth explosions, we see it on the surface as earthquakes and volcanoes.
There's a great analogy for this. Think of an earthquake like a whistling kettle. It isn't just random chaos. It's the planet's safety valve. It's the Earth's crust whistling to let off an unbearable amount of steam and pressure from inside. So how does all that internal pressure actually move entire continents? Well, the process starts deep on the ocean floor. There is this huge crack called the mid-ocean ridge that runs along the seabed. Molten rock erupts from this crack and gets thrown to both sides, acting like a giant, super slow conveyor belt that pushes the continents apart inch by inch over millions of years. And the proof? It's literally staring at us from any world map. What was once a single supercontinent got ripped apart by this process into the 5 continents we know today. And you can still see it. Look at the curve of Africa and the bulge of South America. They fit together like giant, misplaced puzzle pieces.
So we've talked a lot about the how. The meteorites, the volcanoes, the continental drift, all the mechanics. But this is where the story takes a huge turn. We're going to shift from the process to a much deeper question, the purpose.
Was this incredibly long, violent, complex sequence of events just a cosmic fluke? A complete accident? Or was there a plan? Was there an engineering goal behind it all? Was it all by design? Well, the source material we're looking at definitely argues for that second option. It makes the case that if you look closely, the planet's features don't seem random at all. Instead, they look like they were perfectly tuned for life to show up and thrive. Let's just walk through the logic here, okay? Step 1, you need water for life to start, right? Boom, vast oceans form. Step 2, you need a bunch of different environments. The balance of land and sea provides that. Step 3, to get different climates, you gotta break up that one giant landmass. So it splits into 5 continents. And the final piece of the puzzle?
just when complex life needed it, green plants appear to create a breathable atmosphere.
So when you line all these things up, the water, the land, the different climates, the air we breathe, it starts to look less and less like a random coincidence, you know? The argument is that these factors are so perfectly connected, so perfectly timed for our existence, that it suggests a process guided by some kind of wisdom and purpose.
Okay, to really hammer this point home, let's just pull the camera back, way back. Let's think about our little planet not just on its own, but in a universe of absolutely mind-bending extremes. I mean, just think about the sheer range of size. On one end of the spectrum, you've got the neutrino, a subatomic particle so small it has zero mass and zero charge. It can pass through the entire Earth like it's not even there. And on the other end, a humpback whale, a 50-ton, 16-meter-long gentle giant. And it's not just size, it's time too. Inside an atom, you have particles like the meson that are born and die in a millionth of a second. Poof, they're gone. Meanwhile, there are ancient cedar trees on this planet that have been standing for over 3,000 years.
And distance? Oh man, we're talking about the tiniest gap between a neutron and a proton inside an atom, compared to the billions of light years separating us from a quasar on the very edge of the known universe.
And just so we're all on the same page about how massive that is, when we say light year, remember that light travels 186,000 miles, not in an hour, not in a minute, but in a single second. Now imagine that distance stretched over a whole year, and then multiply that by a billion. The scale is it's almost impossible to comprehend. But out of all these wild comparisons, this next one might be the most stunning of all. According to the source, you could take the entire genetic code, the blueprint for every single human being who has ever lived, from the very first to all of us today, and it would all fit inside a tiny little thimble. It's a powerful reminder that when it comes to meaning and information, physical size is almost beside the point.
And that brings us to our final big question, the one to really chew on. In a cosmos of these insane extremes, of infinite smallness and unimaginable bigness, where a thimble can hold the entire story of humanity, what is the true measure of things? Is it size? Is it how long something lasts? Or is it something else entirely? Something to think about for sure.